So I've gone ahead and installed an input planing gear shaft and an output planing gear shaft. There's typically 4 of these, but I've left those removed so that you can clearly see what's going on inside. So the input side has 4 clutches, the output side has 3, 4 times 3 giving us 12 gears. So what we're doing with the input set, as you can see inside here, is we have our input shaft, which is driving our planing gear shaft. And until we turn on a clutch, nothing happens. So I'm going to turn on the 1A clutch, which is this red one. We've just locked this sun gear to the case. So this is unable to rotate. And we're going to, as we rotate the input shaft, it's going to turn this planing gear shaft. But this planing gear shaft is contained inside of this common carrier, and it is forced to rotate around this locked selector sun gear. So as I rotate the input shaft clockwise, you'll notice that the carrier is turning anti-clockwise. There are 4 distinct ratios in the input set. So as I cycle through these clutches, it will change the speed and torque of this carrier. So then moving on to the output set, we have essentially the input set flipped. So instead of inputting on the sun gear, outputting on the carrier, we're now inputting on the carrier, outputting on the output sun gear shaft, which is this one right here. So what happens when I turn on an output side clutch, like this orange one, is as I rotate the carrier anti-clockwise, notice the direction rotation of the output shaft. See how it's going in the opposite direction of the carrier, and therefore the same direction as the input shaft? What we're doing here is the carrier is being driven by the input set, but since it's the same carrier and it's always connected 1-to-1, the carrier is forcing this planing gear shaft to rotate around this locked selector sun gear right here. This is the one splined to this orange clutch. So as the carrier is rotating the planing gear shaft around that, it is forcing the output shaft to rotate. So that's how the forward gears work. There's 3 distinct ratios in the output set. So 4 times 3 giving us 12 speeds. So how do we get reverse? We get reverse for free because, as I've already mentioned, the carrier is already rotating in reverse at an underdrive ratio. For shallow reverse ratios, we can use this sliding clutch right here. I'm gonna go ahead and turn it on with the software. Reverse engaged, forward, reverse, forward, reverse, forward. So what we're doing here is there's 2 methods. There's the simple method. What we're doing with this is we're simply locking the output set to itself. So if this is forward operation, you can see that the gears are functioning normally. When I engage this clutch, you'll see that they're locked up to the carrier. So the